Let's talk about the concept of double circuit substitution problems. It's a little strange, requires a little more intellectual horsepower. I'm going to show you how this works. I'm going to do that first problem for you, and obviously it'll be posted above the start of this entire section of problems. I'm going to do what I normally do as far as like write my equation. Okay, I'm going to pick a nice lighter color than this. Let's take that guy, right? Actually, let's take this one first. We're going to have to mark, this is going to be I1, right? He is I2, and of course, he would be I3. Okay, so we're going to find the currents going through each one of these loops, essentially, right? So for the first one, I'm going to put just I1 so I have an indication what's going on. It's going to be simply 16 times I1 minus I2, right? Plus 8, because now we're looking at this guy. Once again, it's I1 minus I2, and its total is going to be 12 volts, okay? For I2, it's just this one loop going around, so we take and we're going to flip this first one. So it's going to say 16 I2 minus I1 plus, and we have the same resistor, essentially, the same ohms, 16 I2 for this guy is equal to 0. Let's do I3. I3 would be equal to this one flipped, which is 8 I2 minus I1 plus 8 I, actually this should be I3. I screwed this up. This is I3. That's going to be equal to 0. Okay? So those are my three players in this thing. So first step, combine like terms while distributing. So 16 plus 8 is 24I1. And then we'll subtract what we're getting here. 16, right? And minus 8, okay? But they're different. This is I2, so it's going to be minus 16 I2. And this would be minus 8 I3. That's what we're looking to. That's going to be equal to 12 volts. Okay, so that was figured out. Let's do this guy. This guy's fairly easy. I'm going to try to keep things lined underneath the chair for when you eventually do the matrix, right? So it's going to be minus 16 I1 plus, and you're going to add those together, the two I2, so it's 32 I2. And we're going to also result with no I3. There's none, so I'm going to put 0 I3. And there's a reason why I'm doing that, because if you do a matrix, you need one for each column. And for the last one, we're going to do this guy. It's going to be minus 8 I3. There's no I2s. Plus, I'm sorry, that's the wrong number there. This is minus 8 I1. I apologize. And now we have 8 and 8, so we have 16 I3 equals 0. Okay. Now here's where it gets a little strange. We want to get rid of one of the variables in each one of these things. What's good is we've been blessed with the fact that two of these things do not have, they're just two variables. But I got to use this one to get rid of this. So what I'm going to do is I'm going to take this guy, and I'm just going to take this thing and multiply it by 2. Now the rules of math, you can do to one side, you can do it to the others. I can look at this one. I'm going to double this guy up on top. Okay? And the reason why I'm going to put this one times 2 is I multiply this guy by 2. I get 48 I1 minus 32 I2 minus 16 I3 equals 24. Multiply the whole thing by 2. Okay? And then if I take this equation right here, I'm going to put him down underneath of it, and you'll see what's going on here. I have minus 16 I1, it's still I1, sorry, plus 32 I2, and I have plus 0 I3. Nothing's going to change, right, with this equation. And you are going to do process of elimination, we are going to get rid of parts of this. So essentially, I'm going to add 0 to this side, and this whole thing goes this way, I add 0 to this side. So I'm just adding 0 to both sides. And what you end up doing is crossing out this guy here and here. Right? So when you do that, you end up with the following. 48 minus 16 is 32. So you end up with 32I1 minus 16I3, right, is going to be equal to 24. Right? Now I'm going to clear this off to do my next stage. Right? So I'm going to do this. Got to get rid of this guy. That makes sense. Get rid of this. Okay. So to do the next part, okay, I can actually get rid of this. I'm going to take a look at my variables, okay, and I'm going to take this guy and manipulate it. So I'm going to manipulate this equation. So I'm going to put 16I3 here, and I have 8I1 over here. Just divide, just divide. That's easy because that means 2I3 equals I1, right? That's important. I'm going to put a circle around it, okay? So now I'm going to take this guy and sub him into here, right there. So 2, for everywhere you say 32, I'm going to put 2I3 minus 16I3. That's going to be equal to 24. I'm going to erase again. So 64 minus 16 equals 48. I3 equals 24. 48. 48. I3, I'm going to put this up here. I3 equals 0.5 amps. Yay. And now I'm going to go through and get rid of the rest of them. Once you get one, you get the rest. So once again, let me erase this. There we go. Becomes much easier at this point to figure out the rest of these, because now we're just going to sub in and start getting our answers. Okay, so first thing you're going to do is plug it in, because this one has nothing here. We could probably cross this out and cross out because they have nothing, right? And you just put I3 in for this one, you can solve for I1, right? So we know that 16I3 equals 8I1, right? So we had this, right? So it's 2I3 equals I1. So this number times 2 equals I1. I1 equals 1 amp. Let's do I2. I2 is, we're just going to use this equation, and you can see that that one's ended up the same way, right? So if I take this, let me erase him. It's just a matter of keeping things organized. If you're an organized person, you will do fine with this. So here's, once again, minus 16 I1, in this case would be 1 amp, plus 32 I2, right, equals 0. Throw this on this time. It's 32 I2 equals 16. I2 must be equal to 0.5. And then the rest is just basically plugging into a RAV table, which we've shown you several times. And you got to make sure you're subtracting. It's all going to end up, because these are halves and ones, you can almost figure out what's going to happen in the midst of this thing. So for this guy, once it does this, and you can see this, these are all going to be a half times the resistance is going to give you the volts. And the same thing with this one. You can easily see that eventually. So that's how you solve it.